Hello and welcome to this Haas tip of the day. So, your boss has asked you to use your machine probe to measure parts while those parts are still in the machine. No problem. But then you ask yourself, how am I actually going to program this? How am I going to program this? Well, lucky for us, in-process gauging is way easier than many might expect. If you can program this, then you can program this. We'll show you the 5 basic steps that we take to measure parts while in cycle. So stick around. Everything for me begins with my setup sheet. So check this out. I've got a block loaded up. Now if you're tightening up those tools by hand, there are lots of good reasons for us to measure our parts while they are still in the machine. We can have the control automatically update our tool wear offsets using macros. We can have the machine alarm out if a feature is out of tolerance. We can even make sure that a part is located correctly. But before we can do any of those things, we have to be able to probe a feature from within our G-code program. If I'm just setting a work offset for the very first time, I'm always just going to use the crazy simple Haas probing pages on my machine, where we just jog our probe up to the part, select our cycle, and run it. Easy, really simple. We've made videos on all of that, and we'll link to those in the description. Now, if we're going to be probing from within a program, we want to make sure that that probe is moving from spot to spot safely. A protected move, important. We also want to make sure that we're not turning the probe on and off more often than we need to, wasting valuable cycle time. For these reasons, whenever I'm measuring a part automatically, I think it's best to use the routines from the Renishaw Inspection Plus software for Haas machining centers. You can download this manual from the Haas website. We'll link to it as well. On a side note, if you have a Haas with a next generation control, you can load up this manual right onto your machine. You can do this with any PDF, picture, or video. Okay, back to probing. This is how we're actually going to get this done. We'll start off with our basic code that we would use with any tool. We're going to call up our tool, our probe in this case, and call up our offsets, just like when using any other tool. With the basics out of the way, we're going to call up our 1, 2, 3, 4, 5. These are the lines of code that are unique to probing. We're just going to 1, start up our probe, turn it on. 2, move our probe into position using a special protected positioning move. 3, probe the feature. 4, move our probe away from the part using another protected move. And finally, 5, we just turn the work probe off. The Inspection Plus manual gives us tons of examples and instructions on how we can accomplish each one of these tasks. For 1, turning on that probe, we're going to use a G65 P9832. The G65 is a macro call, and the 9832 is the subprogram that contains all of the code needed to turn the probe on. Easy, probe on. 2, we'll use a G65 P9810 protected positioning move to position that probe. This is explained in detail in chapter 5 of the manual. The probe will move to whatever XYZ position we command on this line, at whatever feed rate we command. 120 inches a minute, 3,000 millimeters a minute is a great feed rate for these protected moves. Now, if the probe happens to hit something during a P9810 move, it's not going to damage the probe. It's not going to break off that tip. It's simply going to register the skip signal and stop safely. This is how we move the probe around on our machine from within a G-code program without breaking it. 9810 moves are super important. 3, we probe the feature. We're just probing a bore here, so we're going to use a G65 P9814. Chapter 7 in the manual gives us all of our choices of cycles, and it shows us the variables that go with them. G65 P9814 D1.3. I used a D1.3 because my bore diameter is about 1.3 inches in diameter. I knew to use the D value because the manual told me. Look at that! The probe turned on, then it moved into position safely with a protected move, then it probed the bore. Now all we have to do is get out of dodge with another protected move and turn the probe off. 1, 2, 3, 4, 5. That was way easier than you expected, huh? So we probed the bore, but where is that bore size stored? Section 4-2, page 34 in our manual, lists out a bunch of cycles and the output variables used with those cycles. We used a G65 P9814, so our size will be located under variable 188. Now, if we wanted to probe something else, let's say the Z face of a part, our code would look almost identical. We would turn on the probe, we would safely move into position, and number 3, we would use a different probing cycle. Our probed Z position is now stored under macro variable 187. I know this because section 4-2 told me. In practice, when I probe something, I'll usually use a macro statement of some kind to process the information. We'll want to bookend our probing and macro statements with a G103P1 and a G103. This will limit the look ahead on the machine and make sure that some macro calls aren't executed too early. We've made a video on this and we'll link to it in the description. Most of my hardcore probe programming, that's an awful sentence, is done with the Inspection Plus cycles. But every day, more cam suppliers are adding these probing routines right into their software. This is Productivity Plus software from Renishaw. Be sure to check with your cam supplier to see what they have on offer. Well, that is it. Thanks for letting us be a part of your success and for watching this Haas Tip of the Day.